What if the most advanced stealth fighters in the world, crafted to vanish from radar, could suddenly be exposed? Imagine the skies, once dominated by silent predators like the F-22 and F-35, now vulnerable to a piercing new gaze. Could China hold the key to unraveling decades of U.S. military dominance? Today, we plunge into the enigma of China's quantum radar, a technology whispered to be the ultimate stealth killer. Is it a game-changer poised to rewrite modern warfare, or just another bold claim echoing through the halls of military hype? The stakes are sky-high, and the answers are anything but simple. Join us as we dissect the science, unravel the skepticism, and explore the high-stakes race that could redefine the future of aerial combat. Buckle up. This is no ordinary story. Stealth technology is the craft of making aircraft vanish from radar's prying eyes. It's not magic, it's engineering. The goal isn't total invisibility, but reducing an aircraft's radar cross-section until it blends into the background noise, like a whisper lost in a storm. How? Angular shapes deflect radar waves away from their source. Radar absorbent materials soak up those waves, turning energy into silence. Designers also tame heat signatures and emissions, cloaking the aircraft in a shroud of obscurity. Picture a ninja slipping through the night, not invisible, but unseen. Since the F-117 Nighthawk rolled out in the 1980s, stealth has been the U.S.'s ace in the hole, letting its pilots strike first and slip away undetected. The F-117 wasn't just a plane, it was a revolution. Its jagged, faceted design baffled radar, proving stealth could tilt the battlefield. Fast forward to today, the F-22, Raptor and F-35 Lightning II embody this legacy, their sleek forms slicing through contested skies. Stealth gives the U.S. an edge, first strike capability and survivability in hostile territory. But it's not perfect. Radar isn't the only threat. Heat, sound, and even the human eye can betray a stealth craft. Still, for decades, it's kept America's air forces ahead. That is, until whispers of a new challenger emerged, China's quantum radar. Could this be the crack in stealth's armor? Let's dig deeper. Stealth isn't invincible. Low-frequency radar can spot it, though with less precision. Infrared sensors track heat trails. Passive systems listen for disturbances without emitting signals. These gaps have always existed, but the U.S. counters them with tactics and tech upgrades. The real question is whether quantum radar changes the game entirely. To understand that, we need to know what stealth faces and why China's claims matter. This isn't just about planes, it's about power. Stealth's dominance hangs on staying one step ahead. Is that edge slipping? Quantum radar sounds like science fiction, but it's rooted in real physics, quantum mechanics to be exact. It uses quantum entanglement, a phenomenon where two particles become linked, sharing a bond that defies distance. Change one, and the other reacts instantly. In quantum radar, one entangled photon probes the sky while its twin stays home. When the probe bounces back, its twin helps decode the signal with uncanny precision. Think of it as a detector so sensitive it hears whispers in a hurricane. China says this could unmask stealth aircraft, turning invisibility into a liability. China's been loud about its quantum radar. State media boasts it can spot stealth planes at long range, claims that send ripples through military circles. In 2016, a Chinese firm announced a prototype, hinting at tests detecting objects kilometers away. But details? Scarce. No public data, no peer-reviewed papers, just bold statements. This fits a pattern. China often flexes ambitious tech to signal strength. Yet, without evidence, it's a gamble to take them at face value. Is this a real threat or a strategic bluff? The answer lies in the science and the skepticism. If it works, quantum radar isn't just another tool, it's a paradigm shift. Classical radar sends waves and listens for echoes, but stealth deflects or absorbs them. Quantum radar, in theory, sidesteps this by using entangled photons to spot tiny signal changes that classical systems miss. It's not about power, it's about precision. China's push reflects a broader ambition, mastering quantum tech for war and beyond. But ambition isn't proof. To see if this stacks up, we need to peel back the layers of theory and reality. Here's the pitch. Quantum radar exploits entanglement to outsmart stealth. Classical radar struggles with noise, random signals that mask faint echoes. Quantum radar, theorists say, uses entangled photons to filter that noise, pinpointing a stealth craft's return signal. It's like tuning a radio to a single station in a sea of static. Lab tests show promise. Entangled particles can indeed boost detection, but labs aren't battlefields. Scaling this to spot a jet miles away is a leap, and the devil's in the details. Entanglement is fragile. Air, dust, heat. Anything can break the bond between photons, turning a quantum edge into mush. Long-range detection. That's a tall order when entanglement fades fast outside a vacuum. Then there's the battlefield. Chaos, not a sterile lab. A practical system needs rugged hardware, massive computing power, and stability under fire. Experts aren't sold. Physicists like Jonathan Dowling have called it promising but premature. The consensus? It's years, maybe decades from prime time. China's claims might be ahead of the curve or off the mark. The science isn't a lie. Quantum radar could work in theory. Small-scale demos prove the concept, but theory isn't deployment. History's littered with tech that dazzled in labs but flopped in the field. China's secrecy fuels doubt. Without hard data, it's a sales pitch, not a breakthrough. Still, the idea is potent enough to rattle planners. If it's real, it's a threat. If it's not, it's a distraction. Either way, the U.S. isn't waiting to find out. Let's see what that means for strategy. If China's quantum radar lives up to the hype, it's a gut punch to U.S. air power. Stealth fighters like the F-22 and F-35 bank on radar evasion to penetrate enemy lines. Strip that away, and they're exposed, costly targets in a suddenly transparent sky. The advantage shifts. China could track and strike first. Decades of doctrine built on invisibility would crumble. It's not just planes at risk, it's the U.S.'s ability to project power. This isn't a tweak, it's a tectonic shift. But only if it works. The U.S. doesn't sit still. Next-gen stealth is already in play. Materials that scatter more wavelengths. Designs that shrink signatures further. Electronic warfare's another card. Jamming quantum signals or spoofing fake ones could blind the radar. Beyond that, the Pentagon's diversifying drones, hypersonics, and space assets reduces reliance on stealth alone. Other threats like infrared and low-frequency radar already push these upgrades. Quantum radar is just one piece of a bigger puzzle. The U.S. has the cash and know-how to adapt. $700 billion a year says so. Stealth's not dead. It's evolving. China's quantum push forces faster innovation, but it's not checkmate. The U.S. has faced counter-stealth before, Russia's S-400 systems, for one, and adjusted. Quantum radar might tip the scales, but it's not the only game. Passive detection, AI-driven tracking, even satellite networks, all challenge stealth. The lesson, adaptability trumps any single tech. America's edge isn't just planes, it's the system behind them. China's move lights a fire, but the U.S. has fuel to burn. Quantum tech isn't just radar, it's power, computing, cryptography, sensing. It's a trifecta reshaping war and economies. Nations are pouring billions into the race. The U.S. has DARPA and tech giants like IBM. China's got state-backed labs and a knack for big reveals. Europe, Russia, even India. They're all in. Why? The first to crack quantum gets an edge. Unbreakable codes, unmatched detection, AI on steroids. It's not sci-fi, it's strategy. The prize is dominance, and no one's blinking. China's quantum flexes are loud. The Mauritius satellite in 2016 beamed entangled photons 1,200 kilometers, a world first. Their radar claims follow suit. Bold, flashy, calculated. It's not just tech, it's messaging. Their signaling capability, even if it's half-baked. The U.S. counters with quiet muscle. DARPA's quantum projects don't scream, but they deliver. Google's quantum supremacy claim in 2019, that's the vibe. China leaps, America grinds. Both want the crown, but the finish line is fuzzy. Whoever wins, quantum rewrites the rules. Military? Sure, radar, missiles, subs, but it's bigger. Secure comms could lock down secrets. Quantum computing could crack today's encryption overnight. Economies tied to tech, think Silicon Valley or Shenzhen, shift fast. It's a global chessboard, and quantum's the queen. The US and China lead, but dark horses lurk. One breakthrough, and the board flips. The race isn't just about today, it's tomorrow's world order. From stealth's clever tricks to quantum radar's bold promises, we've traced a clash of tech and ambition. China's claims spark intrigue. Could they pierce the US's invisible shield? The science says maybe, but the hurdles scream caution. Stealth's under pressure, yet America's not standing still. The global quantum race heats up, with power hanging in the balance. Will China's radar reshape warfare, or is it a mirage in a Titan's shadow? Time will tell. One truth shines. This isn't just a tech story, it's a saga of strategy and survival. Love this dive into the quantum frontier? Hit like, drop a comment, and subscribe for more cutting-edge insights. The future's unfolding. Don't miss it.